And Sadie.
See what's going on?
Hi, Candace. All right. Here we go. So, yesterday's work came up with some unique and not all unique situations. All of the ones that are unique are minimum requirements to make the conclusion that two triangles are congruent. And so, those are the ones that were the side, and I'll explain a little more about this. The side, angle. The angle, side, angle came up with unique, and then the angle, side. And that was it. Okay, those four things. Luke.
Wouldn't the angle, side, angle be the same as angle, side?
It pretty much is. Exactly. Because once you have two angles, you can figure out the third. Yeah. So today's goal is to talk about why we like these, because they make our work shorter. So I'm going to write those over here, those abbreviations. And then also talk about what they are really saying. But first, let's just look at what you know from chapter 1. From chapter 1, you know a little bit about congruence relationships, and a congruence relationship uses that symbol. And so that's just saying two things are congruent, and they don't use an equal sign because a triangle doesn't have a numeric value assigned to it, unless we're talking about area. So it's like a shape. Is the exact same size as another shape, okay? And if you have two triangles congruent, then 6 different statements could be made. And I believe in the beginning of the year we talked a little bit about this, like the correspondence relationship is important, like order matters. So angle A in this picture, let's try that again. Angle A and D are congruent. So do you remember this from the beginning of the year? Like the order mattered, right? And so this tells us B is congruent to E, and then C is congruent to F. So you know that these 3 things are true. And you also know that AB is congruent to DE, and then AC is congruent to DF, and then BC is congruent to EF. So there's 6 different things that we could say when we have congruent triangles, but to prove two triangles are congruent, you don't have to prove 6 things. You just need to come up with 3 in a specific combination, and that's why those are handy. So those minimize our work. So the goal is eventually, starting next week, you're going to take different situations and prove triangles are congruent, and instead of having to go through 6 steps, plus other things, you have to have 3 key congruence relationships.
There's 7, considering that you're,
So, in other words, if this is known here, somehow, then all 6 of these things are things we can conclude. Does that make sense? But we don't, that's not efficient to work with 6 things when you can work with 3 things. So, down here, but that's all I wrote here. To prove 2 triangles are congruent, you only need to have 3 pairs of congruent parts in the correct combination. Okay, so an example of the one that wasn't correct was side-side angle, because it came up with at least 2 solutions, or sometimes 2 solutions. So these are conjectures, and you should be able to make a sentence statement of those. So
what about the angle?
Remember the angle. The example I used, or the counterexample I used for that, is equilateral triangles all have angle relationship, but they're not congruent.
Right.
Right.
So that's not part of the conjecture.
That's right. That's why I don't have it written down there. I just have these 4. Does that make sense?
Yes.
Did I miss something?
No.
Okay. Okay, so this is how you would say it. this stands for, if I ask you to state it, if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So an example would be, this could be like a fill in the blank on a quiz. You know, complete the statement. And I would say complete that side angle side statement, and maybe, you know, it would look like this. If blank and the blank of one triangle are congruent to blank and the blank of another triangle, then the 2 triangles are congruent.
I don't remember what it was.
Well, you have to think about it. So the letters tell you. If 2 sides and the included angle, because the a's between the s's, are congruent to 2 sides of the included angle of another triangle.
Do you have to say included?
Yes, because it's a different theorem. Remember, this relationship didn't work. The angle has to be between. So you could say it differently. If 2 sides and the angle between the 2 sides of one triangle are congruent to 2 sides and the angle between 2 sides of another triangle, then the triangles are congruent. So we'll practice that. I think after yesterday you get the order matters. You do need to be able to speak about it correctly. Okay? Good? Okay, so in case you don't know what the included side looks like, or the included angle, pictures are going to be marked. So this would be 2 angles in the included side. All right?
Oh, yeah.
Yeah. Okay, so just a couple of problems here. Like, see the 2 triangles in this picture? From that picture, you can conclude that 3 pairs of corresponding sides are congruent from the markings, right? So this is way easier than anything you would ever do on a test. But I want to make sure you understand the easy. You can conclude that triangle KEI is congruent to triangle TEI. And does the order matter? We're saying T and K are congruent. It matters.
Yeah.
We're saying that KE is congruent to TE. It is. Okay? And that EI is congruent to itself. So your work today is pretty simple. You're going to give a statement of congruence, and then you're going to give a reason. So this would just be by the side theorem. Not very complicated. Some of the pictures get harder. Okay, so reading the directions, using only the information given. That means you can't assume anything. How about on the floor? Just put it on the floor. Determine which triangles below are congruent and state which congruent shortcuts you use. So the shortcuts are just side, side angle, side angle, and angle, side. I will tell you that sometimes you'll look up your answer and you'll have a different answer than the book, and the book might not be correct, or they might have an alternate solution. And the reason is I did 2 sections at once because I think it's silly to break them up. And so the book in 4.4 might not know that you know 4.5, and they say you don't have enough information once in a while. So if you disagree with the book answer before you decide you're wrong, ask me. Okay, so for example, I did a look and, well, what do you guys know? Do you even understand the question?
Yeah.
Okay. So Zach Walder, tell me what you know. Anything congruent? Zach.
Yes, C, A, B, and F. Wait, what is that? F, Y, T. I think, I'm pretty sure they're congruent.
F? P. Sorry. Do you have glasses?
Yeah, but I need to get contact.
Okay. Here, is that better?
Yeah. So C, A, B, and P, Y, T are congruent. I think, are they all congruent? No, No, it's cab.
Let's put some color in here, watch this, how about a little color? Okay, so those are here, do you see that?
Yeah.
And then we have the doubles.
I think they're all congruent. Yeah. Yeah, they're all congruent.
Then we have the triples. So we can't do side at all. Can you see that?
Angles are the same too. Yeah.
But do you see that we can't do side at all?
Yes. Yeah.
Okay. And then we have some angles, true. So like this angle, I'm just going to color. That was marked with a 1.
Yeah, it's a side angle side.
There we go.
There's CAB and
It's a side angle side. We know triangle CBA.
QW.
No, it would be
Well, you could say CAB.
Oh, good.
If I did CBA though,
Right.
it has to be SQW.
Yeah.
And if I did CAB, it has to be SWQ.
So that's,
And this is by side angle side.
Isn't PTY, or I don't know what order we, so is it, yeah, PTY congruent too? No, because it's not, but if it has these two sides the same, and the angle is also the same, then that third side would have to be the exact same length, right?
Not necessarily, because this,
angle can
look at
change.
this yellow piece here, Luke. You don't know for sure, what angle P is.
So angle C and angle P could be different.
Don't rely on the picture. Don't rely on the picture.
No, I know, I'm not, but I don't see how it wouldn't be congruent, like, can you just show me how, like?
Well, the picture's bad, but this angle P is not fixed, so this could be like that. Remember, you can't rely on the picture. It's the example we came up with yesterday. It's a bad picture, but by the information given, it's not enough information because you don't know P is fixed. Yeah, can I give you a specific example? It was what we did yesterday. It's a good question. And it was this one here. I think I made it a little bit, remember this?
The line was long enough to.
Yeah, but you're relying on the picture. That's the problem you're having is you're focusing on the picture and you can't rely on the picture. They're purposely trying to mess with you. So, if you have this situation here, where we have these three, we could make the yellow triangle and we started with the green triangle. And then we also found out that this length here could be put in over here. This length could be put in over here because E was not fixed.
Angle E was.
Angle E. What are you doing, Max? Why?
I can't see.
I don't know how to help you guys. Okay. He's gonna miss you. Grace might not, but.
Can't see.
Oh, Sadie. Darn it. All right. You gotta cut me some slack, you guys. I've been
He's
teaching
gonna watch us and be like,
so many years.
feel like no one misses her because we all said hi, can't see.
I did. I talked about her twice just by her sister's name. All right, time out. Here we go. Let's go.
I say, I didn't forget about you.
There you go. So this is it, guys. Let's just do a couple more practice and then you can do your work. So here's things you can assume. Two things. You can always assume the same segment's equal to itself and draw it in the picture. And you can always assume vertical angles are congruent. right here. Okay, and then, so those are things you can assume. Here are things you know. You know alternate interior angles of parallel lines are congruent. That's not, so when I say things you can assume,
Yeah.
the things from that are printed in red, you can take from the diagram. In your book, anything that looks like a line is a line. Okay, in old books, they used to have to state it was a line, but they don't do that anymore. Okay, so I can assume, I can conclude this is congruent to this because they're alternate interior angles. Because of this relationship
Oh, yeah.
here. And similarly, because of this relationship here, I can conclude that this angle is congruent to this angle, but I don't need all of that. So really, the idea is never mark more than 3 things, because later I'll explain why, but it becomes complicated. So pick your
Because then
3.
you have only the angle side angle, right?
Yeah,
That's
just
what
mark
that
what you need. So this could be angle side, that's a legal one. The way I've marked this picture, I can say triangle TSU.
Wait, so what's the difference?
Well, but you have to have it as STU because that's what the problem I was asking.
Oh, I didn't read the problem, thank you. So, I forgot it was up there. So STU would be the same as V, because S and V are the same.
VUW.
VW.
VW,
Oh, yeah.
U.
My question is how do you have angle side? Because there's always a side between angles, right?
Okay. Thumbs up or thumbs down on the middle problem? Okay. Next. Tell me what your question is.
Actually,
Okay, well, let me know. This is ADB. ADB is congruent to what?
well, AD and DC are
CDD.
CDB. And the reason is angle, side.
Wait, what's the difference between angle side, and angle side, angle?
The position of where the side is relative to the angle. So look at that other example here. This is where the side's between the angles. So it would be like angle, side, angle. Here the side is not between the angles, so the S is not between the A's.
Oh, okay, I see that now. Yep, okay, that makes sense.
So, Waldrop and Solano, what about the last one? Do we have enough information to prove the triangles are congruent? Zach, sorry. Chris, you answer.
I can't really.
What's the matter?
People,
You guys shouldn't sit there if you can't see. Okay. So this is marked congruent to this here. Do you see that?
Yeah.
And we also have some,
We have some interior angles that we can use.
these are equal, right?
And then the X.
These are equal.
So it's,
All the
Angle.
angle, and then you have.
yeah.
Angle is not a theorem.
Side angle.
But the yellow, look at the yellow line, it's not between, like in this triangle 1, it's between the 2 blue angles. And here, it's in triangle 2, it's between the blue and the red angles. Right, so here's where a lot of people mess things up. There's not enough information, so you can say it cannot be determined, but that's all you can say.
But if you have 3 angles and 1 side length,
Yeah, isn't it just side, side, side? Because all the sides have to be the same.
So that all the angles work, you're giving one side length and you're giving three
No,
angles.
but you have to all the sides.
You have enough information.
No, you can't, because you can make a super huge triangle that's like.
But you still have one side that has to be the same.
But it's not in the same relative position.
Okay.
It has to be in the same relative position. Girls, do you want to share?
Yeah.
No. Do you? Okay. So what you cannot do, guys, is don't write C, B, D here, because then you're saying this is congruent to some other triangle. And then I'm going to mark you wrong. And I'm going to take points off. So you cannot complete this if you cannot determine. So don't fill it in. Because once you fill it in, you're saying there's a congruence relationship. Man, can you tell that it's Friday? All right, so, yeah, just write it, yeah, like I did.
Or like on top of the line.
Yes. If you, I mean, don't put initials because then it represents triangle, yeah. You're right, cannot be determined somewhere, I'm gonna get it. Okay, that's all you can handle. So the worksheet, 4 and 4 and 4, 5, that's what you do. That's the idea.
I just thought